Hey everyone, and welcome to today's Explainer. I'm Architect A, and I'm joined by my awesome colleague, Architect B.
Hey there! I am incredibly thrilled we're doing this, because today we're diving into something that sits at the absolute heartbeat of modern cloud architecture: reliability. If you've ever stared at a broken production system and thought, man, whose job is it to fix this? Well, you are in the right place.
So let's start with a quote. Reliability isn't created during an incident, right? Okay, let's dive into this because it is such a profound truth. Think about it. When a massive outage hits, what happens? Total scramble. Organizations pull people into war rooms. Everyone's debugging frantically, slapping patches on things. But real, true reliability, that is built through thousands of tiny, completely mundane decisions made way before that incident ever even occurs. It's the culmination of every code commit, every architecture review, and every single deployment script.
Here is our blueprint for today's session. We're mapping out 6 key areas to help us really understand organizational resilience. First up, the ops problem myth. Then, the reliability roster. Third, we'll look at the anatomy of a GCP incident. Fourth, building a blameless culture. Fifth, the ROI of shared ownership. And finally, leading a resilient organization.
It's a packed agenda, so let's just jump right in.
All right, Section 1, the ops problem. You know, early in my career, I remember this absolute nightmare of a production outage. The system went down, alarms were literally blaring, and almost instinctively, the entire engineering floor just turns and stares at the operations team. There is this deeply ingrained yet totally false belief in a lot of organizations that reliability belongs to just one single team.
Absolutely. That old mindset completely isolates the problem. People just assume, oh, the cloud team or the SREs, they'll just fix it. But look at the cloud-native reality. A modern platform is this incredibly complex web of applications: Kubernetes clusters, CI/CD pipelines, managed databases, identity providers. A single weak point in just one API or one bad deployment script can bring down the entire customer experience. Reliability just cannot be isolated. It is the natural outcome of our collective engineering practices.
Which brings us nicely to Section 2, the reliability roster. Because modern systems are so deeply interconnected, building resilient platforms actually requires an entire ecosystem of rules. Developers, for example, they kick the whole thing off with resilient application design, writing idempotent APIs, baking in retries with exponential backoff, and making sure logs actually mean something.
Right, and then cloud architects lay down the foundation. They're the ones designing multi-region architectures, setting up bulletproof disaster recovery, and ensuring secure networking.
Exactly. Then platform engineers step in to provide operational consistency. They're out there building infrastructure as code, managing the Kubernetes platforms, and creating those golden templates everyone uses.
Meanwhile, your site reliability engineers, or SREs, they're zooming out to focus on system-wide platform improvements. We're talking SLIs, SLOs, error budgets, and serious capacity planning.
And we definitely cannot forget security engineers. They protect availability by aggressively driving down risk, handling vulnerability remediation, threat detection, and identity management. Honestly, a security incident basically becomes an availability incident most of the time.
So true. And finally, rounding it all out, product managers align all this tech with the actual business. They're the ones defining acceptable downtime, locking in service commitments, and figuring out release strategies. It really, truly is a team sport.
Okay, let's look at Section 3, anatomy of a GCP incident.
Now, what's really interesting about this setup is how we can take all that high-level theory and apply it to a real-world Google Cloud scenario. Let's see how shared ownership behaves when things actually break in production.
Let's set the stage here. Picture this. Our architecture relies on a global external application load balancer, routing traffic to containerized applications running on Cloud Run. For the data layer, we've got Cloud SQL plus memory store for caching. We're keeping a close eye on the whole shebang with cloud monitoring and cloud logging, and obviously, all our deployments are totally automated using Cloud Build and Terraform. It is a solid, robust, modern cloud setup.
But what happens when a deployment goes sideways? Let's say at minute 0, a subtle, sneaky configuration error gets pushed via Terraform deployment and Cloud Build.
By minute 5, that error cascades. We start seeing intermittent API failures on Cloud Run, and the global load balancer starts catching those issues.
Minute 8 hits, and cloud monitoring and logging are just lighting up with anomalies. Now, in a traditional environment, this is exactly where the panic and the finger-pointing starts. But in a mature, reliable organization,
By minute 45, the team has not only resolved the issue together, they've actually kicked off a long-term improvement plan.
And the way they reach that rapid resolution is the perfect showcase of cross-functional ownership. Nobody is sitting there blaming the deployment engineer. Instead, developers are analyzing how the app behaved during the failure. Platform engineers are digging into the Terraform automation to figure out how that config slipped through. SREs are examining the alerting thresholds in cloud monitoring so we catch it faster next time. And architects, they're reevaluating the big picture resilience patterns. The incident literally becomes a shared opportunity to bulletproof the entire platform.
Which takes us right into Section 4, building a blameless culture. What we just saw in that GCP example, that wasn't just flawless technical execution, it was flawless cultural execution. The technology stack you use, whether it's GCP, Azure, AWS, is incredibly important for sure. But the culture of your engineering organization is just as critical for keeping the lights on.
Absolutely. And the absolute cornerstone of that culture is the blameless postmortem. This is an incident review process that focuses purely on system learning and continuous improvement, rather than assigning individual blame. Think about it. When an engineer makes a mistake that brings down production, their very first thought shouldn't be about losing their job. It should be about how the system actually allowed that mistake to reach production in the first place. Blameless postmortems create the psychological safety engineers need to be transparent, which is literally the only way you can ever fix the real root cause.
So the crucial point we want you to take away is this. Technology enables resilience. Culture sustains it. You could build the most beautifully architected, multi-region, automatically scaling cloud infrastructure on the planet. But if your culture is toxic, if development is walled off from operations, and if people are punished for systemic failures, your reliability is going to inevitably degrade over time. Shared ownership is the actual engine that keeps the platform stable.
All right, let's talk numbers in Section 5, the ROI of shared ownership.
Look, breaking down organizational silos and building up this blameless culture, it takes a lot of time and effort. It takes leadership buy-in and a real shift in daily engineering habits. So, what's the actual business value? What does a company tangibly gain from treating reliability as a shared responsibility?
The return on investment is massive. Because ownership is shared, teams naturally invest heavily in automation, and that high automation maturity leads directly to frequent, low-risk deployments. Plus, when things inevitably do break, because everyone understands the system and your observability is highly mature, you get a blazingly fast mean time to recovery, or MTTR. Ultimately, this shared ownership translates directly into a rock-solid platform, faster feature delivery, and much, much greater customer trust.
Finally, Section 6, leading a resilient organization.
Creating an environment where every single decision, from writing a line of code to designing a network, contributes to service reliability doesn't just happen by accident. Leaders have to be intentional. A really common toxic mistake is treating reliability strictly as an ops problem or obsessing over uptime metrics while totally ignoring technical debt.
Exactly. And the best practice to counter all that is making reliability goals highly visible across all your teams. Leaders cannot just wait for a catastrophic outage to suddenly start investing. You have to proactively sponsor long-term architectural improvements and constantly invest in continuous engineering enablement. You've got to empower your teams to prioritize resilience right alongside shipping those shiny new features.
So I want to leave everyone with this final, somewhat provocative thought to chew on. Who owns reliability in your organization? Really think about it. If your answer is one specific person or one isolated team, it might be time to rethink your approach. Modern cloud platforms are simply way too complex to isolate this responsibility. 100% reliability isn't a department, it's a culture, and it's a mindset. It is the collective responsibility of absolutely everyone involved in delivering value to the customer. Thank you so much for joining us for this explainer, and we will catch you next time.